Hello and welcome back. Today we're going for part 7 of the Mad Robin 3D printer build, design and build, and in this episode we're going on a slight tangent. We're revisiting the hot end mount because the hot end mount that I have right now is very advanced, it's very light, it works very well. But unfortunately, because of the simple way that it's designed, it has the potential to have a little bit of a wiggle. So the tap up and down works absolutely perfectly, and the tap is easy to engage, but unfortunately the whole construction has a bit of a wiggle to it, and that doesn't really impact printing because there are magnets up in the top that hold it to the block of the rail, and when it's down it will engage into the magnets and it will be very sturdy. But when I am trying to engage the tap to find the zero position on the heated print bed, it tends to tilt a little bit, and it's a very small error that can occur then, but I think we can improve on that. So I went back and I did a lot of redesigning, and since I already have like 6 or 7 iterations of the mount plate to the block, I went back all the way, and we're going back to the basics and looking at all of the iterations that I went through. I'm going to go back to the simplest one and just going to try and print something where we can insert LM4UU linear bearings into the block, try to get it quality-wise as good as we can get it, and see if we can make the wiggle go away by supporting the rod that does the up-down movement with a bearing. Also, this should fix one issue that I've been having, and that is that as I'm printing at quite an angle to the rods, I'm also putting a little bit of strain on the rod and the copper shafts, the copper tubes that it is, no, it's bronze, they're bronze tubes that it's moving through. They actually tend to bind on the ABS, and sometimes the tap is a little bit hard to disengage. And I think we can fix that too. So let's move over to the Voron and get a print ready so we can try to make that part new and see how it turns out, because I think that's not going to be the most simple of prints. I'm currently trying to get the Voron up to temperature, and since it's winter it's quite cold in here, and one of the methods that I found that works particularly well is that when I set up the heating, I also turn on the Nevermore filter with its fans, so it circulates the air inside of the printer. And as you can see, we're at 95 degrees with at 90 degrees with the heated print bed, but the extruder, which is resting right above it, is just at 18. So we started out with 15, so something's happening, but most of the temperatures inside of the printer are still very low. But what we can do is we can go into the menu and we can start the Nevermore fan at a slightly lower RPM, and it's going to circulate the air inside of the printer, and that gives us better heat soak. And with better heat soak we have less warping, mostly less undesired warping along the z-axis, and it just makes for a better print. Especially because the print that I'm doing now, as I said, is going to have a lot of support and very close materials. So the wall of the support material and the print itself are going to be very close to another, and if you want those to separate perfectly, you don't want any warping from uneven temperatures. So what we can see is the temperature of the EBB board inside of the extruder is creeping up now, and we can basically accelerate that. Also, the heated print bed has dropped a few degrees, and that is exactly what we want. We want the temperature from the print bed to go to the inside of the printer, and because the printer is fully enclosed and the extraction fan inside of the printer is off, it will actually preheat the space inside of the printer. So let's give this another 20 minutes and then start the print. So just in case you haven't come across a Nevermore filter yet, it's this box right here. It's inside the printer. It's filled with activated carbon, and it has two fans that circulate the air through the filter, and its purpose is to remove the smell from the filament, especially when you're printing ABS, and it works miracles. Most other printers have the Nevermore right in the front here, before the print bed, but it didn't fit for me, and I thought I wanted to have it further in the back. And this position also works very good, and if I want to improve this, I can put another Nevermore on the other side of the print bed. So I am very happy with this, and this is a great addition to any fully enclosed 3D printer. And just for reference, in case you didn't notice, this is the Big Tree Tech variant of the Voron, and this has been a very good addition to my printers, and it just does an absolutely fantastic job. Okay, roughly 2 hours later, it's done. So let's have a look what we get. Now, this looks pretty organic. Let's see if it's already, yep, it's popped loose. And as you can see, the bottom surface is just one surface, so it's extremely important that all of the lines are perfect with the printer, because otherwise we're not going to get all of the support removed easily. But it looks quite alright. Yeah, let's take it over to the bench and have a close look. Okay, so just for reference, this is the old part, and there it goes. This one was printed lying down, so flat on the print bed. The new part is printed standing upright on the print bed. And the main reason for that is that the holes where I want to put the linear bearings into don't come out well enough when I'm printing it lying down. So my hope is that If I print it standing up, then the bore will be more consistent, and even more important, it will be sturdier. And let's try to remove some of the support material that we have here and have a look at how this turned out. For reference, this was printed at 80% speed of the normal speed, and I reduced the flow rate of the filament by 10%, so I would get a little bit more crisp outlines, and I would get the filament to bond with smaller lines. Yeah, let's see how this turns out. So the support is coming off very easily, and seems that it will be able to split. Yeah, it splits really nicely. We can see some artifacting from the internal structures, but that's not a problem. So yeah, let's get this apart. I'll bring you back when I'm done, but oh yeah, this is so simple, and even all of the internal parts come apart really easy. So yeah, this should be a walk in the park. Yeah, I'll look at this. These bores look absolutely perfect. Great. Here comes the other one. Yep. Nice. That was it? Yeah, that was it. Yeah, this piece looks pretty much the way I wanted it to look. Absolutely perfect. And the part that I need to be perfect are the bores. They need to be exactly at a spacing of 20 millimeters. And the holes for the magnets need to be absolutely perfect, so I can set the magnets in there with glue and basically attach it to a block and then have the glue harden, and when I pull it apart, the magnets will be sitting absolutely flat face to face on the block. And those are the small things that just make for much a better result, because this thing has to be mounted to the block perfectly. There shouldn't be any movement in there, and the switch should be very easy to engage and disengage. Yeah, this looks good. I'm going to try this one out. Comparing it to the other one that I had, you can't actually see that much difference. So with this one, the top looks a little bit better, but I can use a file to file that down until it becomes flat. But the difference in the hole spacing and the quality of the bore is very easy to see. Yeah, it's a lot better. Here it is. Just simple assembly, nothing special. And I have 4mm brass rods with 22mm screws inside of them, and they go through the small bearings that I bought. So these are 4mm inner diameter, 8mm outer diameter, with a length of 10mm. or 12 maybe. And yeah, this is very good. It is very solid. It doesn't twist at all. It engages and disengages easily. And right now there's no magnet in there. I haven't added the magnets to the top to make sure that it's held in place. This is just running on the spring of a single switch. So this is very good. It's a very good result. Yeah, I'll have to take it back apart, but well, just so I can put all the inserts in here and try to add at least one magnet at the top, maybe two, I don't know yet. I had the idea that maybe, because the main problem with the existing switch is that the faceplate here can rotate slightly because it's not fixed to the rods super tight. For that reason, I was going to only use one magnet for the top, and I would put that magnet in the center and not the two outside positions. But this is so sturdy. I might even use two magnets on the outside just so it really clamps it down when the switch is not engaged, and so that when it's printing, there's absolutely no movement in the hot end, and everything is just tied down a lot tighter than it is now. Not that that's really a problem. So even now, the print results from the 3D printer are already pretty much excellent, but this could just push it this tiny bit further. And still, even with the linear bearings in there, it is still going to be possibly one of the lightest hot end mounts around. So this thing should be able to accelerate like a champ. Yeah. The only thing that I haven't gotten yet was somebody actually contacted me and offered me shoulder bolts, which are basically rods with a thread at the bottom and a screw top at the top, and they would be 20 millimeters, but I haven't gotten anything yet. I'm still waiting for them. Okay, I assembled two of the new parts. I'm pretty happy with the quality. I measured everything and it lines up perfectly. This one I used for testing the positions of the magnets. So I will be using two magnets at the top to fix the plate to the block of the rail, and one in the front just to provide a little bit of a pull towards the block. I think we could do without this one, but I'm not sure about it, so it doesn't hurt to have a magnet in the front. I have two of the LM4UU linear bearings. Unfortunately, for the four that I have, two of them arrived broken, and I will have to replace them. One of them is missing balls in the ball bearing part. The other one is missing them too, but they're still in the little plastic container, so I might try to put them back. But yeah, it seems like two of the four bearings have puked out their balls. Sheesh. All right, now I'm going to demonstrate with this one. I hope there won't be any parts falling out. Okay, so this bearing slots in here, and it's a perfect fit, absolutely perfect. And measuring it, the distance is perfect too. And this will be going against the block of the rail. So That is very simple. The 0 switch will rest in this part here, and I will be gluing it to the plastic part, which in the past has worked out very well. The spring of the switch is going to aid in the return of the tap, and the magnets at the top are going to latch it to the block when it's all the way down, making sure that it can't pop off while we are printing, so we get perfect print quality. We don't have any wiggle in there because we have the linear bearings. And yeah, so I went ahead and I assembled one of these. So we have the linear bearings in the bore. We have the brass pipe on a screw that it will be running on. This is tightened down to the block perfectly. I made sure that the cuts on the brass are perfect, and this engages and disengages perfectly, and it is so smooth. It's way better than having the brass run on the ABS of the print. Even with any lubricant that I could find, this is way better, and it doesn't increase the weight of the whole construction that much. I'm also leaving the X switch where it was, and it is going to be homing on Z maximum, no, Z minimum, Y maximum, and X minimum. We can fix that in software, and it's no issue, and it works out perfectly. So the next thing that I need to do is I need to glue everything down and get it attached to the existing block. That shouldn't be a problem, because I realized, because everything is screwed down on the block and the rail, I can just open 4 screws and I can just remove this rail. No problem. It wasn't designed for that, but that is pretty neat. That it's so easy to change parts without taking the printer apart, where on other printers you would have to disassemble the printer completely just to get this rail out. I didn't design it that way, but yeah, it works. Also, for glue, I am using this Patex Repair Extreme. I stumbled onto this just by accident. It is absolutely, it stinks. It gives you headaches. If you get it on your fingers are going to hurt. But as for being a glue, it's absolutely perfect. And it works perfectly with ABS. It works perfectly with metal parts. And when you want to take it apart, it stays kind of soft. So you can get stuff apart after having glued it together. But still, the power of the bond is pretty good. No affiliation. Right. Like I said, what's missing are the shoulder screws that I wanted to use instead of the brass rods, but they are a no-show, so I'm going to be staying with the brass rod and screw combination for now. So I'm going to get this ready, and I will try to get it attached to the rod and replace the parts that are on the printer right now. So this here is the hot end removed. The only thing holding it to the block are these 2 screws that have the brass rods over them. They're held in place with Loctite. That works pretty well. And yeah, all that I have to do now is I have to pop off these two switches that are glued on, and I'm going to have to move them over to this new part and then just mount the new part to the block again. It's super simple, and all the wiring, all the switches, heater, thermistor, they all travel up this one umbilical cord, and there's just one. So this is simple by design, but looking at it now, it seems quite well. Also, looking at the hot end, it seems, yeah, it seems to be working out really well. I'm quite impressed with this thing. I mean, this was less than 20 euros on a sale. It's supposed to be Bamboo Lab compatible. They did a good job designing this, a really good job. And all of the heat extraction through the block, cooling it effectively, that seems to work perfectly. So it's a really good design, and it's light. It is extremely light. Okay, sufficient time has passed. The glue has set, and we're basically ready to put everything back together again. I just wanted to show the whole hot end, the way it goes together. So this is the back plate that goes to the block. This is the part that holds the hot end itself. The two of them are just screwed together like this, so you can remove this from the printer without removing the plate holding the hot end, and you can remove the plate holding the hot end together with the home switches directly from the block, and rail and block can stay on the 3D printer. And also you can just remove the rail and block altogether without removing any more parts of the 3D printer, so that's pretty nice. Now everything is greased up. I fixed the linear ball bearings in here, and I'm going to attach it to the rail and block now, and then let's see if this works. So this switch is going to be the spring for pushing the tap sensor back down, and yeah, everything should be there. So let's try it out. All right, we're back on the 3D printer, and what a difference. This is super nice. It moves a lot easier than the original one did, and if I really mangle it, I have a bit of movement in there, but it's a lot firmer than it was before. So yeah, let's go with this. There's still some flexibility in here, which is okay, because if we run into something, we want this part to give, and not the hot end parts. So yeah, let's get this screwed on here, and then let's see if it still moves as easily as it did before. And it's done. I'm not 100% sure that this is a lot better, but yeah, it feels like it. What's definitely better is that I need less force if I'm pushing from the top of the nozzle, I need less force to move the switch up, and I see less bending in the mount part. I do see some flexibility when I wiggle down here, but it's pretty minimal. But I was actually hoping that that would be better. And I have some movement when I move it back to front. I'm not sure that that was there before. But maybe this will improve when I get the shoulder bolts and screws to replace the bronze tubing. So yeah, I'm looking forward to that. Apart from that, yeah, I'm going to attach the fan to the front of the hot end, and I think I'm going to give it a try and see what happens. Okay, time for the first home. Let's see if it works. So yeah, it's definitely working, but I'm not 100% sure that it isn't still flexing a little bit. Let's see if we can get a little closer and try it again. Yeah, there could be a little bit of movement inside of the hot end part. It's better, but I'm not 100% sure that it is perfect. Let's go up a little bit and try again. Touching. Yeah, it's almost nothing. So I'm pretty happy with the result. That being said, I'm not, well, I'm not absolutely sure that the movement that I'm getting when I touch it like this, I'm not sure that this is better than it was before when I had 3 big magnets holding the plate to the block. There's a bit of movement in there. Maybe I should try to improve on that, but that being said, the nozzle is a lot closer to the center of the block at the front of the plate, so there is movement, but it's pretty minuscule. So I think I'm going to have to do some test prints to figure out if this improved anything. The thing that it did improve was that there was a lot more flex in the upper part here before, because the Z-axis really had to press down on the print head to force the tap. Now that requires a lot less force now. I'm not 100% sure that I'm happy with this result. The part that I had before was seemingly still pretty good. Alright, let's do a test print. Okay, so I stopped that Benchy print early because there was actually nothing to be learned from it. The prints look pretty much exactly as they did before. So the change to the plate didn't have any negative effects. It seems to me that it has a lot of a better time homing, so I'm calling that an improvement. And I will have to do some more printing of larger objects to see if I can see it different in the print quality, or if any of the vibrations that we're seeing, that when this thing moves a lot, that it makes it through to the print. But right now I can't see it. So I'm calling that a success, and I'm pretty happy the way it went. So I think this is going to be it for this week. Thank you very much. Thank you very much for watching, and bye bye.